All right, so the top is your parent function. It should take you like a minute to do this top part because it is all just the parent function. Your table should be 4, 1, 0, 1, 4. Your parent function starts at a vertex of 0, 0. That means it has the axis of symmetry of x equals 0 because that has to be the x of your vertex. So 0, 0, 1, 1, 2, 4, 3, 9, and then the mirror images of those. And then you've got this nice little U shape. And your axis of symmetry is on the y-axis, x equals 0. And let's label that axis of symmetry. If you're going to label the axis of symmetry on your graph, I need to see that it's the axis of symmetry. Otherwise, I might think that you actually think it's supposed to be there. Make sure it's dashed so that you're telling me you know it's invisible, you know it's not supposed to be there. Domain for this is all real numbers or negative infinity to infinity because your parabola is just going to keep getting wider to the left and wider to the right. What's the lowest y value you can be? 0. What's the highest? Infinity. We can't include infinity, so that's going to get a parentheses. Can we include 0? Yeah, we have a vertex at 0, 0, so we need to include 0 by putting a bracket on it. What questions do we have about the parent function? We should be able to graph y equals x squared in our sleep. If you can't, we need to be in tutoring. All right, now we got to graph this function, and I kind of warned you that you're going to need to factor today. Notice that there is a 1/2 multiplying with the x on the inside of your function, so are we going to need to factor this? Yes. And I'm actually going to show that factoring right next to where I said yes. If I take the 1/2 and I multiply it with x, that's going to give me 1/2 x. What would I multiply the 1/2 by to get the 1? 2. So plus 2. And then transformations in the correct order means you need to go from left to right in your function. First, we see the 3 on the outside. What is that going to do? Vertical stretch by 3. All right. What does the 1/2 do? Horizontal stretch by 2. Good. And then that 1 is really this plus 2, which is going to do what? Left 2. And then minus 5 does what? Down 5. So I'll start with 0, 0. If my original vertex was 0, 0 for my parent function, when I transform it, that's going to get me my new vertex. So that's the important part. 0, 0 is not going to be vertically stretched. It's not going to be horizontally stretched because both values are 0. I am going to move it to the left 2 and down 5. Oh, what is happening there? Okay. And my new vertex would be -2, -5. What does that mean my axis of symmetry is? X equals -2. Remember, you're giving me the equation for that line. And let's draw that on our graph just to help us out later. And I'm going to label it AOS for axis of symmetry. My next point on my parent function was 1, 1. I'll show you the path up here, and then I'll erase all the points that are not supposed to be there. But you start at 1, 1. If you vertically stretch that by 3, you're going to go up to 1, 3. And then if you horizontally stretch that by 2, you're going to go to the right 1 to make that horizontal distance 2. So 2, 3. And then you move left 2, so you're at 0, 3. And then you move down 5, so you're at 0, -2. And then that is 2 horizontal units away from our axis of symmetry, so I can reflect that across the axis of symmetry by going 2 more horizontal units. That's why it's helpful to draw the axis of symmetry, so I don't have to go through the motions of transforming the point -1, 1. You can do that, especially if you want to check your work, but sometimes this can be faster. What's the next point on my parent function after 1, 1? 2, 4. So if I go to 2, 4, I'm going to vertically stretch that by 3, so where's that going to go? It's going to go to 12, okay? And then if I move that horizontally stretch by 2, then that's going to go to 4, 12. I'm putting it kind of in the location it would be. If I take 4, 12 and I move it left 2, where's it going? Back to 2, 12. And then if I move down 5, where's that going? 2, 7. So out 2, up 7. That's our new point. If my point goes off my graph, I will write down the ordered pairs so I can keep track of where I'm at. That is 4 horizontal units away from my axis of symmetry, so I can reflect that by going 4 more on the other side. And now we have our nice little parabola. Bless you. Make sure you're making a U shape and not a V shape. These are gentle curves. What's my domain? Yes, all real numbers. You can also say negative infinity to infinity. I'm going to start using interval notation more often than not. What's the lowest y you can be in your range? -5. What's the highest? Infinity. I can't include infinity, so it gets a parentheses. What about -5? Yes, bracket, because I have a vertex at -5. What questions do we have? I'm going to move away from inequality notation and start doing interval notation, because interval notation is going to be more helpful as we get through Algebra 2. But inequality notation is still correct as long as I don't ask you for interval notation. Does that answer your question? All right, the bottom one, I've got 1, 2, 3, 4, 5 transformations in the bottom one. So will we need to factor the inside? Yes, because there's a negative, right? So yes, there's a -1 multiplying with our x, so we have to take that out. -1 times x will be -x, and then -1 times what will give me this -2? +2. So yes, we need to factor the inside. Now we got to go in order. Let's talk about this negative in the front first. What's that do? Reflection over the x, okay? What about the 3? Vertical stretch by 3. What about this negative? Reflection over the y. And then this -2 is actually this +2, so where's it going? Left 2, because it's actually a +2 when we factor it out. And then what does +8 do? Up 8. I'll start with 0, 0, so I can get my new vertex. If I start at 0, 0, reflecting over the x doesn't change it. Vertical stretch by 3 doesn't change it. Reflection over the y doesn't change it. Left 2 changes it, and then up 8 changes it to 2, 8. What does that mean my axis of symmetry is? Oh, I'm so sorry. -2, 8. X equals -2. Okay. If I start at 1, 1, reflection over the x will put me at 1, -1. If I vertically stretch that by 3, that's going to put me at 1, -3, because you're multiplying the y by 3. And then it's got a reflection over the y. I'm 1 unit away from the y-axis, so I'm going to go 1 more on the other side. It's going to be -1, -3. And then I'm going to go left 2, and then I'm going to go up 8. So you should end up at -3, 5. That's 1 horizontal unit away from your axis of symmetry, so you can go 1 more on the other side and graph your reflection point. That way I don't have to worry about transforming -1, 1, and now I can go to 2, 4. So if I go to 2, 4, reflection over the x will put me at 2, -4. Vertical stretch by 3 puts me where? 2, -12. If I do a reflection over the y, where does that put me? -2, -12, because you're going to change or make the x value negative. So that was my reflection over the y. Now I got to go left 2 more from -2, -12. Where does that put me? -4, -12, right? And then up 8 will put me where? -4, -4. And then from there, that's 2 horizontal units away from my axis of symmetry, so I can go 2 more on the other side and graph that reflection point. Domain, again, is all real numbers or negative infinity to infinity. Somebody tell me the range, including notation. This one's a little bit different. Okay, negative infinity, comma. Then where are you going? 8, bracket, parentheses of negative 8. Good. So negative infinity with a parentheses on it, comma, 8 with a bracket, because you're going from negative infinity up to 8. It's always got to go bottom to the top. What questions do we have? All right, let's look at note set 2. All right, we'll do number 11. You don't have an example to do after 11. We'll do 12, and then you'll have an example to do. So number 11, what should we look for first? GCF, do we have one? Yeah, what do they share? A 6, so let's take that out. 6 times x to the 4m. 4m will give me 6x to the 4m. And then minus 6 times what gives me 24? 4y to the 8n. If we look at what's inside the parentheses, do we have 2 terms? Yes. Is there a difference? Yes. Are they perfect squares? Yes. So we can factor this into a difference of perfect squares. So 6, and then we'll split this into 2 factors. What multiplies by itself to give us x to the 4m? X to the 2m. Remember, you're adding your exponents when you multiply these x's. So 2m plus 2m gives us 4m. Minus, let's not put my signs yet. What multiplies by itself to give you 4? 2, and you're going to have y to the what? 4n. And 2y to the 4n. I almost wrote 2. 4n. And what are my signs? Plus, minus. Remember, we're trying to get that middle to drop out. So plus, minus. Do x to the 2m and 2y to the 4n share anything? No. Then you're done. If they did share something, that would tell you that you didn't take out your greatest common factor when you could have. Number 12. Do we have 2 terms? Yes. Is it a difference? Yes. Are they perfect squares? No. Is there something they share? Yes. What is it? 3. Let's take that out. What's going to be in my parentheses? X to the 8 minus 1. Good. Inside the parentheses, do we have 2 terms? Yes. Is there a difference? Yes. Are they perfect squares? Yes. So let's go ahead and factor this into a difference of squares. So we've got 3, and then difference of squares here. What multiplies by itself to give you x to the 8? X to the 4th. And x to the 4th. What multiplies by itself to give you 1? 1. This one's a whole lot of fun. Hey, do me a favor, okay? Put your plus first, and then your minus. Okay, all right. Look at this next term, this middle term right here. Is it 2 terms? Yes. Are they perfect squares? Yes. Is it a difference? No. Then this one doesn't factor anymore. Hey, 2 terms? Yes. Difference? Yes. Perfect squares? Yes. We can factor it again. So let's factor it again. So we've got 3 times x to the 4th plus 1. That's not going to change. But we can factor this last one. What multiplies by itself to give you x to the 4th? X squared and x squared. What multiplies by itself to give you 1? 1 and 1. Hey, do me a favor. Put the plus first. Then the minus. With x squared plus 1, there's 2 terms. Tell me why it's not a difference of squares. Because it's adding. So the middle is not a difference of squares. Is the last term a difference of squares? Yep. Yeah, so we can factor that. So let's factor that. So your other factors will stay the same. 3 times x to the 4th plus 1 stays. X squared plus 1 stays. Now we get to factor this last one into what? X plus 1 and x minus 1. Is x a perfect square? No, then we don't have any more difference of squares. We're done. What questions do we have? You ready to try one on your own? No. It'll be fine. Oh, I need to remember it's up here. That was number 12, yes? So you're going to do number 21. So do number 21. That one. 21. Nope. Yes? Yeah? If you got that, give yourself a little smiley face on your paper, because that's awesome. Maybe later? Alright. Oh, okay. We gotta go back and do 13, right? Yep. So when you're ready, go back. We're gonna do 13. No. No. This one, what are we gonna want to use for it? A and B. Yeah, so A is gonna be x plus 3. And let's make B x minus 4. So then if we use substitution here, this would be a squared minus b squared. Not quite. That's a squared plus b squared, but good thinking. A squared minus b squared, there's two terms. They're both perfect squares, and they're being subtracted. So let's factor it as a difference of squares. So that's going to be a plus b and a minus b. Yes? Now here comes the weird part where we have to sub things back in. If we made a x plus 3, then wherever we have a, we're going to put x plus 3. So here and here. If we made b x minus 4, we're going to have to be careful with b, and I'll show you why. But we're going to put x minus 4 in for this b and for this b. So for the first set of parentheses, a was x plus 3 plus b was x minus 4. In the second set, a was x plus 3. What are you doing with b here? Subtracting it. If b is two terms, you're subtracting both terms. So we're subtracting an x and we're subtracting a negative 4, which is what? Plus 4. That's why you have to be careful when you're using substitution here. Now we can combine like terms in each set of parentheses, only within one set at a time. So x plus x here is 2x. 3 minus 4 gives you negative 1 in your first set of parentheses. In your second set, what happens?
X's cancel out.
The x's, okay, use a better word than cancel out. They make 0, okay? And 3 plus 4 gives you 7. A better way to write this is 7 times 2x minus 1. It's crazy that something so complicated ended up so simple. We started with something complicated, and it ended up simple. You think that's complicated? Yeah. Let's see how 22 goes. Yep, try 22. Same idea as the last one we did. So try. What'd you make A?
21.
What? X minus 1. So for this one, we want to make A equal to X minus 1. B is equal to X plus 2. So we have A squared minus B squared. That factors into A plus B times A minus B. When I plug it back in, A was X minus 1. You're checking your own work. B is plus X plus 2. A is X minus 1 minus B is X, and you're also minusing a 2 there because you're subtracting all of B, so it should be minus X and minus 2. In your first set of parentheses, X plus X is 2X, negative 1 plus 2 is plus 1. In your second set, X minus X is going to make 0. And then negative 1 minus 2 is negative 3. So this should have been negative 3 times 2x plus 1. If you got that, put a nice little smiley face. Positive reinforcement tells your brain that you did something good, and so you should do it again. What questions do we have? Are we getting the hang of it? Gonna do well on our quiz on Monday? Yeah, you are. It'll be fine. Let's go backwards. Let's see. What else do we have to do? Did we just do 13? Yeah. 14? Let's go back and do 14. 16 looks scary? It won't look scary. It's not bad. Why does 14 look scary? Fractions. We gotta take out at least the denominator, right? So here, what would we have to take out? 1/3. So let's take out 1/3. And then if we take out 1/3, 1/3 times 2 will give us 2/3. That gets an x to the 8n. Minus, what times 1/3 will give me 8/3? 8. And that gets a y to the 2m. Is there anything that these share? A 2. So we can also take that out, yes? Where's it going to go as far as 1/3 is concerned? Numerator. So now we're going to take actually 2/3. And we're factoring out a 2 on the inside. So that's just going to be x to the 8n minus, that one's going to be 4 because we're factoring out a 2, y to the 2m. Now what did we make? What's on the inside of the parentheses? 2 terms? Yeah. Difference? Yeah. Perfect squares? Yeah. So we can factor it as a difference of squares. So we got 2/3 times, what multiplies by itself to give you x to the 8n? X to the 4n, because when you multiply these, you're going to be adding the exponents. What multiplies by itself to give you 4? 2. And what multiplies by itself to give you y to the 2m? Y to the m. Y to the m. Does x to the 4n and 2y to the m share anything? No. So plus, minus, and we're done. So what made this one different was the fraction we had to factor out first. You do number 23. So try number 23. It's the 2/5 problem. I'm going to put this back on the problem we just did in case you need to look up for an example. 3, right? I saw most of us got this correct. Make sure you're checking your work. Some of us jumped straight to taking out a 2/5, which is a good idea. 2/5 times x to the 4n minus 4y to the 2m. I say check your work. You also need to check mine, because who knows. And then that's a difference of squares. So 2/5 times, and then x to the 2n will multiply by itself to give you x to the 4n. 4 is 2 times 2. And y to the 2m is going to be y to the m times y to the m. And then add and subtract. If you got that right, give yourself a nice little smiley face, because that's awesome. I see good things happening around the room. And we're almost done, which is great news. Oh, man, where did I put my notes? There they are. All right, let's backtrack. Number 15. You want me to? So we'll do 2 examples. I'll do 2 examples, and then you'll finish it? You want to do that? Okay. So we'll do 15. I want to use substitution for 15. So A is going to be 2x minus 4, and B is going to be x minus 1. That means the first part would be A squared minus B squared. This is very similar to one we've already done, except now you've got that 2x, which will be a little bit different. A squared minus B squared is 2 terms. It's a difference, and it's perfect squares, so it's a difference of perfect squares. It'll factor into A plus B times A minus B. For my A's, I'm going to want to sub back in after I've factored. I want to sub back in this 2x minus 4. And then for my B's, I'm going to want to factor in wherever I have a B. Oh, man. Come on. I know, it just runs down the page. X minus 1. Be careful when you're subtracting. And so A plus B will be 2x minus 4 for A, plus B is x minus 1. and then a is 2x minus 4, and then you're subtracting both parts of b, so you're subtracting an x, and you're subtracting a negative 1, which is going to be what? Plus 1. So you got to be careful there. When I combine like terms in my first factor, 2x plus x is going to give me 3x. Negative 4 minus 1 is negative 5. When I combine like terms in my second factor, 2x minus x is x. Negative 4 plus 1 is negative 3. And that stays because 3x minus 5 does not have anything in common with x minus 3. The last example that I'll do with you is 25. Nope. You're going to do 16. I'm going to do 25. The difference, so you don't have to flip there. Go to 25 because I'm going to do 25 with you. Do you know what 16 is made up of? Do you know how to read that? Sine and cosine. Okay, the difference is tangent and... Exactly. You haven't seen these. You've seen tangent. You haven't seen secant yet. And so I'm doing the one that you don't know yet so that you can go back and do sine and cosine. Works the same way. So here, I'm going to use substitution. I can say A is equal to tangent of x and B is equal to secant of x. Secant is spelled S-E-C-A-N-T, so secant. That's going to get real dangerous real fast. Yeah. So this is a squared minus b squared, which factors into a plus b times a minus b. And so now I'm ready to plug those back in. A was tangent of x plus b was secant of x times a was tangent of x minus b was secant of x. On 16, I don't care if you put parentheses around your x. You can write the trig function right next to x like we did in number 25, if that's easier for you. I think they put like double parentheses in number 16. I really don't care that you put sine of x. That's the same thing as sine of x. Same thing. And that's it, yes. Questions on 25? I'm going to give you 4 minutes to try to get 16 and what's the other one? 24 done. So get 16 and 24 done in the next 4 minutes, and then you'll be done with note set 2. What can you work on after you get the all clear from me? Homework. You can also look back at previous homework to study for your quiz tomorrow. And Math Excels, yes, because Math Excels, they're all due on Tuesday, and there's 3 of them. So make sure we get those done.